All right, so today we're taking what we did with vectors and moving along to like applications. How can you actually use it for something besides just writing a vector because you want to write a vector? So a note here, bearings. So a bearing is your angle or angle of a line of travel you make with due north. So like a ship or a plane or something usually goes off a bearing versus standard angle. So your standard angle would be the blue 25 right here. You're coming from the x-axis and going counterclockwise. A bearing comes from north because it makes more sense to think about going straight and then veering off from that versus coming from the x-axis. So a bearing comes from north and goes clockwise. So here, our first example, your standard angle is 25, your bearing is 65. There's no like 100% obvious way of how to switch between the two. You just have to think a little bit and like look at your unit circle. So if we do the 91 here, a bearing of 90 degrees, so we start here, we go 90 degrees. This would be your 90-degree bearing. And you think of what would that be in terms of your standard angle? Well, you're at the x-axis, so your standard angle is 0. So pause the video, do the next couple of these, and then I'll talk through them. Okay, so a bearing of 300. This would be 0, and then all the way around would be 360. So 300 has to be somewhere here-ish. Make that a straight line. So say this is your 300 bearing, went like this. And then to figure out the standard angle, we want to come from the x-axis. Now if I come this direction, this is 90, and then I have a chunk extra. So I have 60 degrees extra because I went 90, and then to go from 360 to 300 is 60. So this one is going to be 150. So 60 plus 90. Going the other way, we'll do blue. So we have a negative 40. So negative 40 is somewhere down here for your standard angle. So now if you're doing bearing, we're coming from up here. So we're coming to 90, and then an extra 40. So this would be a bearing of 130. And again, there's no like 100% always add 90, always subtract from 180. It depends on where you are in the unit circle. You need to think through how do you adjust to get the angle you want. Okay, so vectors and modeling real-life situations. For example here, we have a plane has a compass bearing of 300 miles per hour and is going straight north on its compass. But there's a wind blowing it out of the way it's supposed to go. So you have a 40 mile per hour wind going northeast. So what we want to figure out is where is that plane actually going? So if I'm coming from here and I make this resultant vector, where does the plane actually end up? Because it's not actually going straight north anymore. It's going a little bit tilted. So how do we do that? First, you want to write the velocity vector of just the plane. So the plane itself was going straight up like this, right? We can think of your vectors again are magnitude, cosine of your angle, magnitude, sine of your angle. So the magnitude is going to be 300, and we're going straight north. So we're not doing any directions, right or left, with the plane. We're just going straight up. So then this would be your vector. So your y direction is 300, your x direction is nothing. So then for the wind, we're at a 30-degree bearing. So we'll call it W. You have 40 cosine of 30, 40 sine of 30. Put this into a calculator and you should get 20 and 34.64. If you aren't, make sure you are in degrees, not radians, because it's giving us a measure in degrees. Okay, so now for the longer section, we want to find the actual ground speed and direction of the plane. So first we need to find the actual vector to begin with. How we're going to do that is you're going to add these two together. So then if we add the plane plus the wind, you're going to add them together so you get 20 and then 334.64. So that's your actual vector for the direction of the plane. So now we need to do what we did before and find the speed and the direction. So I'm going to call this something else just so I can not write p plus w. So let's call it the true vector. So if we want to find the magnitude, do it in a different color, or our speed, we want the magnitude. So 20 squared plus 334.64 squared. Take that square root and you'll end up getting about 335 miles per hour. Now we need to find the direction. So your direction, this was your speed. You want to take this, again, this is where I do the cosine, but you could do cosine or sine. So A is equal to the magnitude cosine of your angle. So A is 20, magnitude is 335, cosine of theta. So theta is cosine inverse of 20 over 335, or this will give me a direction of 86.58. Again, make sure this is going the right way. So you have 20 and 334, so we're going like this. 86 is also going like this, so we're good. But we need to convert to a bearing still because it asked for the bearing, not the angle. So if we're at an 86.58 angle, the bearing then is going to be 90, subtract that. So your bearing is going to be 3.42. So your magnitude is 335 miles per hour at a bearing of 3.42 degrees. Okay, so another one, but with a ship. Try this one and then come back and watch me do it. We have a ship traveling 22 miles per hour along a compass heading, so a bearing, of 110. The current is flowing northeast at 3 miles per hour. Find the actual speed and bearing. So step number 1, draw a picture. So we have a compass bearing of 110, so this direction. It will draw for me. And so we'll call this the ship. And then you have current flowing northeast. So northeast would be like this a little bit. So northeast at 3 miles per hour, call this current. And all it was 3, and this one was 22 miles per hour. And then we want to figure out the actual ship. So we'll call this the true bearing again. That's what we're trying to find. So it just gives you an idea of about where you are. So if we find the ship currently, we're going 22 miles per hour at a bearing of 110. So here, before I can plug anything in, I need to switch my bearing to, what's it called? Oh, a standard angle. Speaking of which, I drew this wrong. So I'm going to erase this and start over. All right, so we have a ship traveling at 22 miles per hour along a compass bearing of 110. So I'm going to draw that first. Again, this is the compass bearing. So if this is my basic unit circle, we're coming from north to 110. So about here-ish is a ship going at 22 miles per hour. And then I need to add on the current, just going northeast. So it's going to be there-ish. At 3, we'll call this C for current. And then what we actually want to find then is the true direction. We'll call that T. So if I want to find the ship, we're at 22 miles per hour and we want cosine of an angle. Here, you should be really careful. It's not going to be 110 because that's your bearing. You need to convert this 110 bearing into a standard angle. So 90 would be to right here, and we're 20 past. So you can do cosine of -20 or cosine of 340. It doesn't matter which one. And then 22 sine of -20 or sine of 340. Type this in and you'll get 20.67 and -7.52. Now find the current. So here we have 3 cosine and we're going northeast. So northeast is going to be a nice 45-degree angle. If it just tells you northeast or like southeast, assume we're exactly halfway in between. So then 3 sine of 45, you'll end up with 2.12 and 2.12. So then your total, or your true vector, if you add them all together, so add this and this, you get 22.795, -5.403. Okay, now actual speed and bearing. So we just found the vector to begin with. Scroll up a little bit. So speed is going to be your magnitude of t. So square root of 22.795 squared plus -5.403 squared. Type that in and you should get a magnitude of about 23.43 miles per hour. Now to find the direction and then to change it into a bearing. So your direction, I again do the one with cosine, but you can do the one with sine. So about 22.795 equals your magnitude, cosine of your angle. So then theta is cosine inverse of 22.795 divided by 23.43. And I'm getting 13.37, which is going like that. But I want to be going down for my angle, so I'm going to make this negative. And then last step is to find the bearing. So if I'm down here, I'm going to add 90 to that to get the bearing. So the bearing is then 103.37 degrees. Move it up a little bit. And there you go. Okay. So here's slightly different. We have two forces, magnitude 10 and 20, shown below. Act on an object P. Find the resultant vector. So direction and magnitude. So first of all, I'm going to take this and redraw it just so it's over here. So it's all connected to each other, tip to tail. Because then what I'm really looking for is this vector. This would be, we'll call it the resultant vector with an R. So I need to write out the two different vectors first. So force 1 is going to be 10 cosine of 45, 10 sine of 45 because of this angle right here. And that will give you 7.07 and 7.07. Then find your second vector with 20 cosine of 150, 20 sine of 150, plug that in, and you should get -10.25 and 17.07. If for some reason you're not getting numbers I'm getting, check to make sure you're in degrees. It's usually the most basic fix. So then our overall vector, or our resultant vector, is going to add those two together, and you'll get, oh, here I wrote down the wrong thing. 1 second. So this should actually give you -17.32 and 10. So then when you add them together, you'll get the negative 17 point negative 10.25 and 17.07. So that then is your resultant vector, added them together. If you have more than one, if you have like 3 of them, you still just add them all together. Nothing special about that. So then to find the force, take the magnitude, so negative 10.25 squared plus 17.07 squared. Take the square root, and you should get about 19.9 pounds. So then you do the direction. Here, it doesn't ask for a bearing, so you can just do direction. So we'll take the x, negative 10.25 equals 19.9 cosine of theta. Theta will then end up being 121 degrees. Make sure it makes sense. That's going this direction. This is going the same direction. We're good. Again, check Schoology for the assignment.